In this video, we will show you how to remove physiological noise from your NIRs data. A majority of the NIRs signal comes from systemic physiology, which is variations of oxy and deoxyhemoglobin in the peripheral tissues, such as the scalp. These variations are due to heartbeat or blood pressure and not cortical activity, so it's important that you remove them from your NIRs signal. Let's see how to do that in Satori. Two options exist in Satori for removing oxygenation variations due to systemic noise. You can either do it during the pre-processing step, or you can include a regressor in your first level GLM analysis. In both cases, the short distance detector, or SDD, information will be processed using the GLM. In the pre-processing option, however, the software will not compute any statistics. Let's first look at the pre-processing option by clicking on Analysis, and then FNIRS Data Preprocessing, and then Advanced. You can see here in the upper right-hand corner under Short Channel Regression that there are multiple options to choose from: the closest SDD in distance, the most correlated, and all the SDDs. Lastly, you can choose one or multiple principal components up to the number of short distance detectors you had in your montage. If you choose this last option, you can visualize the component you will remove by pressing on Show Comp. Moreover, if we press on Go, then the software will create a new SNRF file containing the pre-processing steps you applied, which is evident by the new file title above the topo plot. Satori will also create 3 additional SDM files. They all start with the same name of the SNRF file you are processing and end with WLPCA-SSRDM. The numbers 1, 2, and 3 stand for the first and second wavelength and the sum of the two. So you should see 3 SDM files ending with WL1 PCA SSRDM, WL2 PCA SSRDM, and WL3 PCA SSRDM. You can load these files as predictors in the GLM by pressing Ctrl-G and then going to Confound/Options. Then you can select the Contrast tab to see how significant the removed component is against the baseline. Now let's focus on how to include short channels as regressors in your first level GLM analysis. First, click on Analysis, and then General Linear Model, and then click on the Confounds Options tab, and check the Add Short Channels Confounds Predictors box, here at the top of the window. By default, Satori adds a short channel signal for each chromophore individually to the GLM as a regressor. If you don't want to include all chromophores individually as regressors, you can select just one or multiple by checking the Use Specific Chromophores box. And then you can click the boxes corresponding to the chromophores you want to include as regressors. If you select Short Channel Regression as a pre-processing option, Satori will fit a GLM for each chromophore and wavelength using the short distance channel signals as regressors. The residuals of the GLM will therefore correspond to what couldn't be explained by the short channel signal, namely cortical signals. The residuals will be saved as the new, cleaned data for further analysis, such as first level GLM with experimental conditions. This allows you to see the clean data before moving on to your statistical analysis. On the contrary, if you use SDD as a regressor in your first level analysis, physiological noise will be taken care of at the same time as computing the beta for your experimental contrasts. Thank you for your attention and see you in the next video.